Okay, so we're going to look at VC Specialist Maths, Lecture 10. We're going to look at quantifiers and counterexamples. So some good prior knowledge for this would be the previous lecture where we spoke about a bit of logic and did some proof techniques. So that was Lecture 9. Put these all in a playlist as well, so you're welcome to go and check that out. The concepts that we're going to cover in this video are going to be quantifiers, negation without quantifiers, negation with quantifiers, notation for negation with quantifiers, and disproving existence and there exists statements. So as we'll talk about in a moment, existence and there exists statements are quantifiers. So let's jump into it and see if we can make some sense of things. So the first thing we're going to say is what a quantifier is. So there are two basic quantifiers. One's called a for all, and then there's a there exists. So for a for all quantifier, basically means we're making a universal claim that a property holds for all members of a given set. So for example, for all integers, n squared is greater than or equal to 0. And I think you would agree with that. There's no number you could pick where when you square it, it's not greater than or equal to 0. So that's making a universal claim about the integer n. Okay, in another quantifier we can have is that there exists, or there is an existence statement that claims that a property holds for at least one member of a given set. So what we could say is there exists a real number n such that n squared equals 4. Okay, so yeah, we're just making a claim that a property holds for one member of a set, at least one. So I think you'd agree in this example that n could be positive 2 or negative 2. Okay, then what we're going to look at is what's called negation without quantifiers. So in the previous video, we spoke about De Morgan's laws, and that's a case where we're actually doing negation without quantifiers. Encourage you to go back and look at those two laws. But the only one I wanted to talk about is this sort of extra thing we can include. Remember, this notation here means P implies Q. And then what we're going to say is, all right, P implies not Q. So that would be a negation of of this statement here. So again, with an example, if it rains, which we call P, then the ground will be wet, Q. So negating that, we get it rains, but the ground is not wet. So P, but P implies not Q. Okay, so that is a negation where we don't have any of these quantifiers here. It's not a for all statement or a there exists statement. But we can have negation with quantifiers, and this is sort of what we want to get to. So to negate a statement involving a quantifier, we interchange for all with there exists and then negate the rest of the statement. So for example, for all real numbers n squared is greater than or equal to 0. This is the example we had before. Okay, interchange for all with there exists. So no longer do we have for all, we've now got there exists a real number n such that n squared is less than 0. Okay, then we negated this. The opposite of n squared greater than or equal to 0 is n squared less than 0. Okay, and then we can obviously see in this example that this is true, but this is false. The negation of this for all statement is false in this case. Okay, we actually have some notation we can put around that, but it's actually not a massive part of the course. I don't think you're expected to know it, but we can, yeah, just what we said before, we can just introduce some notation. So for all numbers n squared is greater than or equal to 0. We use this upside down a to mean for all. So for all n element of real numbers, n squared is greater than or equal to 0. So that's how you would write it, sort of using logic notation. Okay, and then this backwards kind of e is a there exists. So there exists some n, that's an element of real numbers, such that n squared is less than 0. So that's how you would write it using logic. Okay, and finally, the last thing we're going to talk about is disproving universal statements and disproving existence statements. So in order to disprove a universal statement, you need to just do the following. You need to find one example where the statement is not true, and such an example is called a counterexample. So just an English example here, or a scenario. A universal statement might be something like all birds can fly. We're making a statement about all birds in that set that they can fly. A counter example would be that there exists at least one bird, an emu, that cannot fly. And that's enough to disprove that universal statement. Okay, sort of similarly, if we need to disprove an existence statement, we need to show that an existence statement is false. We prove that its negation is true. So if our existence statement is something like there exists a person who can hold their breath underwater for 30 minutes without any assistance, such as oxygen tanks or special training, our negation of that would be there is no person that can hold their breath underwater for 30 minutes without assistance. And then what you would need to go and do is prove that that's the case. So, um, yeah, you go off and prove that however you need to. Obviously, the examples you'll be dealing with will be um, mathematical statements. So you have to go and prove that negation is true to disprove an existence statement. And then we got our emu here trying to fly. It's got a weird number of legs, but that's what AI will do. Okay, hopefully you found that useful. As always, if you're finding these videos useful, please consider subscribing and leaving a like or a comment. Um, yeah, because I want to get this out to as many people as possible and help them on their maths journey. So good luck, and I'll talk to you soon.